Okay, the idea between question 1 is basically you need to re-express the gx, okay, into a suitable form so that you can see the sequence of transformation. So for each part, you want to ask yourself this question: how do I write gx as afx, afcx plus d plus b? Okay, so that means in this case, there must be some way where I can express ln 3x minus 2 raised to the power of 5 as a ln cx plus d plus b. So how do I do that? Bring down the power. So essentially, I apply the law of logarithms. So each part has its own learning point. Okay, so part A teaches us that you see logarithm, you apply law of logarithms. It's actually a very simple idea. Okay, so let's do that. So ln of 3x minus 2, 5. Okay, is equals to 5 ln 3x minus 2. Okay, so we see that the A is 5, the C is 3, the D is minus 2, and the B is 0. Okay, so we will now start our sequence of transformations. Okay, what is the first thing we should do? This is my starting. Okay, this is my starting location. This is my destination. So I look at the very complicated MRT map. I must decide which line to take, where to transit. So what line do I take first? Northeast line, Thomson line. You all don't know how to travel, man? Huh? Come on. Do what first? Scale first. Is it? Who says scale first? Okay, scale first. So I replace x with what? 3x. Okay, the weight first. I know you weight what already. Okay, I will come back to your weight. Okay, so the x will become ln 3x. Let's just put it this way: many roads lead to Rome. Okay, so not just one road. Unless your weight is for something else. Okay. Then what do I do next? This is the challenging part. You can get past the next one. It's easy. Oh, I haven't said the transformation. So sorry. So what's the transformation? Scale parallel to the what axis? X-axis by a factor of 1/3. So okay, so you always take the reciprocal of the coefficient of the variable. That is your scaling factor. All right. Okay. So when we say factor, we don't say. The sound doesn't bode well. Never mind. Okay. So you don't say units. Okay. You don't say units. You only say the word units when we are doing translation. All right. Okay. So next, do what? Oh, by the way, Which of these two is the transformation? This one or this one? If I ask, take a sequence of transformation, which is the transformation? This one, because got students get confused before. They write their whole list, replace what I what, replace what I what, replace what I what, then finish. That one you write to guide you, but that is not the transformation itself. Okay, so this then is the transformation. Okay, next. Become what? Y equals to ln 3x minus 2. So 3x minus 2 is replaced by what? Which is it? 2/3. Why is it 2/3? Yeah, you only change the x. You never disturb any other things that's not inside the x. Okay, so you have something like this. I highlight what is changed, so that's easier for you to see. Okay, so the transformation is translate in the which direction? Positive x direction by 2/3 units. Okay, so then you get the one you want. Okay, and then lastly, you replace what? Yes. Okay, so I suggest you write this first. Don't immediately write y equals to 5 times of this, because you want to see for yourself what is the replacement, right? Okay, so this is scale parallel to the y-axis by a factor of 5. Okay, so you see how I said you take the reciprocal of the coefficient as the scaling factor, right, in the previous step 1. Okay, so it's consistent with this. That is why you need to write the replacement. If you don't, you immediately write y equals to 5 ln 2x minus 3, you may not understand why the scaling factor is 5 and not 1/5. Okay, now I come to my next question. There are a total of 3 steps in this transformation. What are the possible orderings in this case? So of course 1, 2, 3, 3, 1, 2. Okay, basically the 3 can be slotted anywhere. Why? Because 3 is a what is this? Vertical transformation. These two are horizontal. So between any horizontal and a vertical transformation, the order does not matter, because they are transforming 90 degrees with respect to each other. They don't affect one another, right? But between two of the same kind, so for example, between 1 and 2, you cannot switch. If you want to switch, then what will happen? Or what must you do? Yeah, you have to do a different magnitude. Okay, so an alternative is that you could have, in the first step, right? You change it to x minus 2 first. Okay, here I replace x with x minus 2. Next, I only touch the x. Right, I only touch the x. Okay, you can only change at one interchange at one time, right? Cannot change 2 times together. That's why maybe in this sense, translation first is faster, or how to say, easier to see lah. But may not always be true. Maybe sometimes you have other teacher who tell you that, oh, always translate first, or if you have tuition, your teacher to tell you translate first. It's just a rule of thumb. Do you know why the magnitude will change for the translation? Okay, so the reason is because you think about it this way. The scaling is like a compression. Okay, the scaling is like a compression. So if you scale first, then thereafter you only need to travel 1/3 units to the right. You compress, then you shift a bit only, right? But if you want to shift first then compress, remember the compress will also shift. Your compression will also compress how much you shifted. If you shifted first, so if you move 3 units, 2 units, okay, your compression will cause you to go back. So I mean, if you want a physical understanding of why this is happening, this is one I can offer you lah. Okay, yeah, so it matters. It matters. Okay, let's go to the next one. Okay, so same thing. We want to ask ourselves, how do we rewrite this into a form that looks like this? So in part A, the moral of the story was you see logarithm, you use law of logarithms. You see a quadratic, use completing a square. Okay, so let's do this one. So we complete the square. Okay, so you divide by 2. Okay, remember to compensate properly. Okay, so in this case, first step, replace x with x plus 3/2. Okay, so we are translating 1.5 units in the negative x direction. Okay, please don't tell me you translate negative 1.5 units in the positive x direction. Never ever use negative numbers as the magnitude of a transformation, be it scaling, translation, or reflection. So for example, how do you say reflection, right? Because sometimes I see people say scale by a factor of -2. Don't do that. Okay, so say split into 2, say scale by a factor 2, then reflect about whichever axis. Okay, so do it properly. Right, so now I have y equals to x plus 3/2 squared. Okay, next, you replace your y with what? Y over 4. Okay, replace y with y over 4. Okay, so you do that. This will be scaling parallel to the y-axis by a factor of 4. Okay, and then lastly, let's simplify this first. Sorry. Lastly, you will replace y with what? Y minus 1? Y plus 1. Okay, so be careful. Okay, so replace y with y plus 1. Okay, so I'm translating in the negative y direction by 1 unit. Okay, so once again, by doing replacement, you see the consistency with x. Replace x with x plus 1 is negative x direction. So therefore, replace y with y plus 1 is negative y direction. Okay, and you will not recognize this if you straight away write the next line. Okay, this is the part that students often get confused about. Here. Okay, so for the next two parts, I'm just going to talk about how to manipulate gx into the desired form. Okay, then the transformations, you take care of it yourself lah. Okay, if not, otherwise it's just you hearing me saying the same thing over and over again. Okay. Okay, C. So we've dealt with logarithms, we dealt with quadratics. Now we deal with rational functions. Lesson number 3. Rational functions do what? Long division. So you do long division. Okay, so y equals to gx, or gx is 2x minus 5 over x plus 2, which is 2x plus 2 minus 4 minus 5. Okay, so this one quite straightforward lah. This one you will have 1, 2, 3, 4. Wow. Translate in the negative x direction by 2 units. Scale parallel to y-axis by a factor of 1 over 9. Reflect in x-axis or y-axis. To answer this question, ask yourself another question. Vertical or horizontal reflection? This is the easier question to answer, right? Vertical or horizontal reflection? Like that or like that? The negative is on the whole function, right? So you're doing vertical. So vertical is reflect about x-axis or y-axis? You are reflecting in the vertical orientation. You are reflecting about x-axis or y-axis? X-axis lah. Okay. Then after that, translate in the positive y direction by 2 units. Okay. The reflection is another confusing part. So a lot of students think, reflect vertically, y-axis, y is vertical. No, because you are reflecting vertically, your mirror is horizontal. Make sense? So likewise, if I'm reflecting horizontally, like how you are with your mirror when you brush your teeth in the morning, there's a horizontal reflection. Your mirror is straight upwards. It's the y-axis. Okay. I wanted to say something else. Yeah. Okay, never mind. That's fine. Okay, so that's part C. Now part D, last one. Part D is not so common lah. Do you also recall your R formula? What's the R formula? Okay. Okay, the R formula, very simple. Okay, I write that easier to remember lah. X plus minus the other way around. Okay, as in the red color is to emphasize to you that if you desire this to be one of them, so let's say sign, you need to make sure your sign comes first. If it does not come first, please don't do anything yet. Okay, switch around the two things first. Huh? Okay, then this one is basically you just take the square root of the coefficients of the two functions. Sorry, the square root of the squares. Sorry, the square root of the sum of the squares of the two coefficients. In English, it's quite a mouthful. Okay, then after that, the plus minus, we'll talk about it later, but no matter what happens, your tangent inverse will always be the second coefficient divided by the first one. Whichever you place behind, that one goes to the numerator. Which one comes first, go to the denominator. Right over left, right over left. Okay, right over left. Now we talk about plus minus. Plus minus is plus, you put sign. Sign you put plus, sorry. Cosine you put minus. Actually, they come from the addition formula. The R formula is a consequence of the addition formula. You know what's addition formula, huh? Aiya. Eh? Oh, no, it's not a consequence of this. Sorry. Factor formula is a consequence. You all don't know what's factor formula, right? Never mind, you soon come to learn. Okay, so anyway, yeah. Okay, so never mind. Anyway, is it relevant? Is it relevant? No. Yes, it is relevant. Okay. It is relevant, it's relevant. So if I go reverse, you see, I go reverse, I show you the magic. Okay. So let's say square root a squared plus b squared. Sine of x plus tangent inverse b over a. Okay, tangent inverse b over a is a very cumbersome expression to use. Let us call this theta. Be patient. Can you construct a right angle triangle for me? This side how much? B. This side how much? A. Okay. This side how much? Okay. So this is, let's make use of the theta. Okay. Now I use addition formula. Right. My triangle got no x. So the sine x and the cosine x, let's just leave them alone. Don't touch. Okay, I'm only going to change my cosine theta and sine theta. Okay, what's my cosine theta? Look at the diagram. A over square root a squared plus b squared. Sine theta is b over square root a squared plus b squared. Do you now see that the denominators here cancel off with what's outside? The proof is happening. So a sine x okay. The reason why our formula works lah. Why is so useful? Why do we learn our formula? Besides transformation of graphs. Okay, because it's always easier to solve something like this compared to something like this. The first one is easier to solve, right? That is the purpose of knowing our formula. Okay. Anyway, I digress. So we come back to this. So what's the first thing to do, by the way? Do I immediately apply our formula? Answer is no. You see, because the thing is that here is cosine, right? So you desire for the resultant to also be cosine. Now, if that's the case, I want to switch first. Yes, switch first. You realize so far for this part, there is no discussion on A level yet. These are all O level stuff. Then now I follow this rule, this R formula rule, right? Okay. Go and check whether it's in MF26. Okay. So anyway, take the coefficient on the cosine and the sine. Square each of them, add them, take the square root. Then when you square the square root 3, please remember it's just 3 and not 3 squared. If not, you will get into a lot of trouble. Next, take the coefficient of the second one over the first one. Then take tangent inverse. Okay, then because the angles now are 2x, not x, so I follow through. What's inverse tangent square root 3? Pi over 3. Well done. It's been a long time. Someone answered me within 5 seconds. That's my rule. That's my 5-second rule. You have your 3-second rule for dropping 4 on the floor. I have 5-second rule for triple. You should be competent enough to answer me within 5 seconds. What's tangent pi over 4? 5, 4, 3, 2. So sad. Okay, let's continue. So yeah, do yourself based on all this. Okay, continue to question 2. Okay, this is a good example of when the translate first, scale later rule will not work. Okay, the thing is that if you try to translate first, I mean you could lah. Yeah, okay, let's say we do a translation first. You will probably go down this route. Then later you're going to have a tough time. You can, but it wouldn't be replacing y with y over 4a. You'll be replacing y with what? 2 square root a. Because of the square outside. Remember the rule about you only touch the x or the y. You only touch the x or the y. So you need to accommodate the square when you are doing replacement of variables. I realize the square is hidden under the arrow. Okay, let me just change that. Okay. You'll see this happen a lot of times when you do conics, which I realize you never talk much about in curve sketching. Okay, never mind. Okay, so go and self-learn your conics. Okay, so I would suggest a different route. Okay, so y squared equals to x. Let me scale first. Because if I translate first, I have no choice. I have to use scaling parallel to y-axis already in the left side. Okay, so I don't want. So I replace x with 4ax. Okay, so this is scaling parallel to x-axis by a factor of 4a. Okay, then you replace your x with not x minus a. X plus a is the easier way. Not the easier way, the correct way. Because if you forecast one step further, remember later when you do your reflection, you only touch the x. So the negative sign doesn't follow through to the a, right? So if you can forecast in advance, you know that the correct move to make is to plus a. Alternatively, you could do your reflection first. So instead of x plus a, you could do your minus x first. But then later on, you will do replace x with x minus a. Okay. So in the face of a horizontal reflection, aka a reflection about y-axis, it will perhaps make more sense to do the translation first. Okay. Okay, and then lastly, you do this. So take note, y-axis. Okay, then there are some of you who may be very headstrong, very insistent. Mr. Lee, but what if I really want to do my translation first before I do my scaling? Okay, method number 3. Not sure if this works. Let's try. So I expand the thing first. I suppose also can lah. So you can translate first. But if you want to translate first, you should translate by 4a squared units. So you sure you want? Okay, you can lah. You have to make sure you expand first lor. Okay, then you do your, what is this? Scaling. Yeah, I'm just going to use shorthand notation now. So I'm going to use this. This is scaling. This is translate upwards, downwards. Then this is reflection. Okay. Okay, then last one. Please don't write these symbols in the exam. Thank you. No, later the marker will come ask me, Mr. Lee, what do you teach your students? Okay. You choose lah. Okay. It's good that you try all 3 because I can tell you certain problems you are stuck with one way, you don't get to choose. So if you are fluent in all possible ways, it will benefit you lah. Okay, let's move on to the second part. Okay, so this is how your curve should look like. Make sure I see symmetry about the x-axis. Do you remember my tip on how to check symmetry of your graph? You don't look at the graph like that. You turn your paper 90 degrees, right? Then you check. Okay. So make sure all the coordinates are labeled in coordinates pair form. Once I use this phrasing, labeling the coordinates of, then your points jolly well be in coordinates pair form. Okay, 0 to A, 0 negative to A, A0, all like this. All these also please label. Okay, then we come to the challenging part, which is actually also not very challenging. Okay, now the next part of the question asks you to find the distance between the origin and an arbitrary point on the curve. Okay, so did they use the word arbitrary? Yes. Who can explain this word to me? Yes, any point. That means in general, it doesn't matter which one. Your formula should work for all of them. Okay. Okay. So now, so you realize sometimes if your comma English is not very good, right? It will affect your math also. Okay. So anyway, we come to this. So let's find a point here. Okay. Now, because this point is on the curve, I can always write it as, let's see. What is a good way to write it? Okay, actually, never mind. Okay, so let's call this xy. I'm interested in this distance. Okay, so now let's work it out. Okay, so using the distance formula. Don't need so many lines. Okay, but if you look closely at this expression, you realize, y square seems to have appeared somewhere already. Right, it had already appeared in the equation of the graph. So perhaps it will be convenient to just substitute the expression inside lah. Okay, so that you can have everything in terms of x. And please remember, the equation is y squared equals 2. So please don't square this thing anymore. Then you are overdoing it. So meaning to say, you keep this as it is, because this already is the y squared. Okay? Then next thing you do is you simplify. Then you realize this question wasn't constructed randomly lah. Why 4a? Why not a? Why is the setter so extra? Go and put 4a. Actually, a, yeah, a will have something else. Okay, so this is a perfect square. I hope you see that lah. How to simplify? Is it x minus 2a? Yes. Well done. It's the modulus. Okay, it's not just x minus 2a. Remember, every time I take the square root of a square, I do not get itself. I get its modulus. So I get itself provided itself is positive. But in the case if it is negative, I will get negative 8. That's why the modulus is important. Okay, now we can answer the next part of the question. What does it mean? Or rather, which line, okay, are all the points equidistant from? Okay, so now you think about it. There's a x minus 2a. Okay, so we are saying that this distance here is modulus x minus 2a. Okay, let's look at it from another perspective. X minus 2a is also the difference between this length, because this is x, right? As well as 2a. Where is 2a? Somewhere here. Can you see? If I take the difference between 2a and x, that means this length here, the red one, it will be equals to the blue one. Okay, and this happens throughout. So it's not to scale lah. If it's to scale, then it's not true. Here and here also the same thing. Okay, so what is this very mysterious line the last part of the question is asking for? It's just asking for the line x equals to 2a. Okay, if you recall from PQ7 in curve sketching, remember this thing? right? Then I mentioned something about how you can construct ellipse using 2 pins, a taut string, and a pen. Yeah. Okay, so in the case of an ellipse, there are 2 foci, 2 focuses. Okay, the sum of the lengths to the 2 focus will always be the same. Okay, you learned 4 conics: circle, ellipse, parabola, and hyperbola. Okay, hyperbola will have something like this. Circle is a very boring result. What we just saw from this question is the one for parabolas. There is a line where every point, the distance to the line is the same as the distance from the point to the focus. In this case, origin is the focus. So we usually write this lah. PF equals PD, where D is the line. Okay. So if you are curious, you can find out more. Okay, I want to talk about the part where we were finding the OP, but I purposely left it till now because it will now make more sense after I explain the line thing. Okay, so actually this can be further simplified. If you look at the whole story, what can it be simplified to? You look at the diagram, where is 2A? It's on the right. Where am I X always? It's always on the left, right? It's always on the left of the line. So the modulus of X minus 2A is always X minus A, X minus 2A, which is bigger, X or 2A? 2A, so which should it be? 2A minus X. Two A is always bigger than X, right? X is the X coordinate of an arbitrary point on the curve. Your curve is always to the left of X equals 2A, right? That's why you can simplify further, and you should simplify further lah. This is not the final, not final answer yet. Okay. So of course, if the story was this way, then the answer would have been X minus 2A. Can? Okay, let's go on to 3. 3 and 4 and 5 are all siblings of the same family. Each with its own quirks. Oh, I haven't done part 3. Oh, part 3 done already. Okay. What is the best strategy I think I should use? You should use, or you think I should use for question 3? Where are the unknowns? In the beginning or at the end? In the beginning. So what do you think I should do? Work backwards. Because the unknown is usually at the end, right? It's the thing you find. Okay, so work backwards lah, huh? Okay, so if I work backwards, I will start from the reverse of 3. Okay, so the reverse of 3 is to translate 2 units. Okay, let me write below. Okay, so when we do reverse our transformations, number one, we reverse the order of the transformations. Number two, we reverse the direction of the transformations. Okay, or the magnitude, depending. So for translation, we only reverse the direction. We don't reverse the magnitude. For scaling, you reverse the direction, it's still the same. Parallel to y-axis will still be parallel to y-axis, right? But now you change the magnitude. So from 3 will become 1/3. From 1/5 will become 5. Right? Because if you were compressing at first, you go in reverse, you are stretching. Right? Okay, then what's the reverse of reflection? The reverse of reflection is itself. Yes, the same. Okay, I hope that makes sense to you. Okay, so number 2 is, okay, so prime just means reverse lah. Okay, scale parallel to the x-axis by a factor of 3. And then last one, reflect in y-axis. Okay, so now we have to identify the replacements lah. Okay, so we start from here. We go through 3' first. 3' is a replacement of y with y minus 2. So let's do precisely that. But after you have done that, you can feel free to simplify as such before you activate the next one. If you don't like negative signs, you can also do this. But if you are very careless with your negative signs, then I suggest you don't do this. Okay. Next, let's put it here lah. We go through 2'. Okay, what was 2'? Scale parallel to x-axis by a factor of 1/3. So x replaced by 2x. Okay, once again, you see some common things. Okay, so feel free to simplify first to help yourself. Last one, we go through 1', which is x replaced with negative x. So in retrospect, perhaps I should not have made this move lah. Because if I had not made that move, then all the things will become positive again. Okay, but never mind, it's okay. We can't always expect to have that much foresight, right? Okay, then that's it lah. At least for this part, right? But we need to go one step further to rewrite. I feel like I did something wrong. Oh no, correct. Okay, so yeah, so I simplify. Please remember how to find common denominator properly. Okay, so in other words, A is 2, B is 5, C is 1, D is 2. Then you will ask me, Mr. Lee, do I need to write all this? Don't need. But you want is good habit lah. Okay. Oh, need. Sorry, need. Okay, because I thought the question was expressed in that form where for some constants A, B, C, and D to be determined. Those kind of phrasing, then don't need lah. But if they write so explicitly, then you have to write out. Okay. Okay, question 4. Yes. Do share. Huh? Do share. Yeah.
I just do all the time.
And you're working forward lah. You need to make sure that your coefficient here is -1. That means you probably will have, I don't know, some very strange things, right? Okay, so anyway, this one needs to be 1. You cannot leave like this and then compare AB with 3, CD with 6. You cannot, because your E may not be 1. If your E isn't 1, everything will collapse. You need to divide by E throughout first. Okay, yeah. But I just thought that perhaps a more intuitive way is to work backwards lah. Not say intuitive. In fact, it's not intuitive. It's more intuitive to do forward, but it's more manageable to do backwards, I would say. Okay. Okay, then we go to question 4. What does your intuition tell you? Work backwards or work forward? Forward, because it doesn't really matter. The unknowns aren't at the beginning, they aren't at the end. Right? At the end is the first few PQs already. We have encountered them already. Right? How to do normal kind. Then I show you question 3, the not so normal kind at the beginning. Now, next layer, beginning, end, all no unknowns in between. Okay, so how to work out? Okay, this one also got strategy involved lah. Okay, we'll do forward. So because we are doing forward, there isn't really much to think about it. We'll do like what Latika mentioned, right? Just do the replacement. Then please make sure you copy the question correctly. Okay, so I'm going to go a bit faster since we are already a bit more fluent now. Right, so I'm replacing, okay, for transformation 1. Oh, okay, thank you. So much for copying the question correctly. Okay, so translate in the negative x direction by A units. I replace x with x plus A, right? Okay, then what do I do? So, yeah, I do precisely that lah. Okay, next. Scale parallel to the x-axis by a factor of b. So x replaced with x over b. Okay, and then this is where things start to get a bit more convoluted. Okay, I don't like so many fraction lines lah. Right? So let's do ourselves a favor and multiply b on both the numerator and denominator. You may not have done this, but this is what I advise you to do. Okay. Lastly, scale parallel to the y-axis by a factor of c. So replace y with y over c. Okay, then of course here, the next most logical and natural thing to do is to combine this into a single fraction so that you can compare with the resultant equation in the question. But it turns out in this case, the most logical and natural thing to do is the less efficient method. Okay, because if you were to combine, I mean, you could lah, but you can see that is a lot of things, right? So why not? Let's be a bit more innovative and creative in our thinking. How about we come in from the other way? Okay, so the thing is that all these so many unknowns. So instead of making something with so many unknowns get to your destination, why not you bring your destination a bit closer to you first lah? Okay, so in real life that's not a good analogy, but anyway, I decompose this into partial fractions. Why you make it sound so horrible? Okay, now, so just like what I mentioned to Latika just now, I need to make sure the coefficients are 1. Once I make sure the coefficients are 1, I can now start to compare apple with apple, orange with orange, quite literally. No, that was a coincidence. Okay, so comparing. If you don't know what to say, just write comparing. Don't write anything else. Yeah, sometimes less is more. Okay, so comparing, BC is 1/4. You compare with the other one, also the same. Eh, something not right. Oh, this is a minus. Okay, so let's call this okay, never mind. Okay, so the orange with the orange, AB minus 9B is -2. AB plus 3B is 2. So technically, you have 3 equations, 3 unknowns, you should be able to solve. The only unfortunate thing is they are not linear lah. They are not like A plus 2B minus 3C. Okay, but you can still try to spot common things that helps you solve them simultaneously. So one thing I can see here is that if I took 2 minus 3, or if I took 3 minus 2, I will be able to eliminate the AB. Okay, I think take 3 minus 2 is better now. Not a fan of negative things now. Okay. And with this, actually, the rest will come out very quickly. Right, so you sub into 1. You sub into 2. Okay. Come out already. Huh? Okay. Yeah, so just try lah. If you encounter this kind of question, don't wow, so scary. Just fall back on your first principles, what you have learned, follow through. Okay. The way I write is the teacher's way to explain and present. So that's clearer for you to understand. When you write a working, please don't write like that. Don't write halfway on the left, then suddenly go to the right, then do your working on the right. Then after that, solve simultaneous, you do 2 arrows here. Don't write like that. Everything nice, line by line down. Thank you. Must state my disclaimers first. Okay. Not later I have a nightmare when I get assignments. Okay, question 5. Question 5 is looks scary, but actually very harmless kind of question. Okay, the key thing to understand in this question is that if x goes to infinity, okay, if x goes to infinity, ax plus b also goes to infinity. For example, if x goes to infinity, 3x plus 5 goes to infinity. Negative 5x plus 2 goes to negative infinity. So right now, I'm not bothered about the plus minus. Let me don't care about the plus minus, okay? I just care about the infinity part. Okay, so why do I say this? Okay, now, once I understand this, okay, in terms of horizontal asymptotes, the only thing that is causing a difference between the one on the left and the one on the right is the plus C. Whatever happens in the F is inconsequential for the horizontal asymptote. You can do 10,000 horizontal transformation. You can scale parallel to x-axis by 10,000. Then after that, translate by -1 million. Your horizontal asymptote will stay at y equals, right? Okay, so only the plus C will cause the effect. So immediately, which is why I say this question is very harmless. 2 plus C is 5, so C is 3 lor. One answer come out already. So in fact, this one, right, you just have curve sketching principles you can also do. You don't need transformations. Okay, yeah. Next. Okay, next thing is the x equals to 3, the vertical asymptotes. Okay. Let's look at the one on the left. X equals to 2 is an asymptote for y equals to fx. This is a geometrical statement, right? It paints a picture in my head. I'm visualizing a vertical asymptote. Okay, now rewrite this statement in algebraic form. I gave you the first word. As x approaches to y approaches infinity. Okay, so now from this point forth, as long as we are talking about transformation of graph, let's not use y. Let's use fx. What's the reason? Y is what? Y is asymptote. No, not quite the point I'm driving at. Y is many things at different times. Y is fx on the left. Y is fax plus b plus c on the right. Y could be 1 over fx in another part. Y can be many different things. So if you write y, it's very dangerous lah. Let's be precise and write fx. Okay. Okay, now I want to figure out x equals to what is an asymptote for y equals fx. Not y equals fx, sorry. Y equals to f okay, for this, right? Okay, so okay, let me break this down for you. I am asking myself this question. Okay, or rather, Not asking lah, but this is telling me this, right? Okay, as x approaches c, a tree f ax plus b plus c approaches either positive or negative infinity. Okay. How do I explain this simply? Does the c really matter? What's 1 million plus 0.1? What's 1 million plus 0.1? What's 10 million plus 0.1? It's 10 million, right? So it doesn't really matter. You see my point? Okay, yeah. So in a way, I have this lah. Okay, but I want a one-to-one comparison with the thing on top. So instead of saying as what approaches 3, I want to say that as ax plus b approaches some number. Okay, now, so if x approaches 3, let's draw a line here. Can we just don't bother about anything above the line first? Okay, so look below the line. So as ax plus b approach what? If x is approaching 3, ax plus b approaches what? If x equals to 3, ax plus b equals what? Yes, thank you. Okay, now we can do a comparison. Okay, you see, the thing is that the ax plus b is just like a variable itself, right? I could say something like this. So let z equals to this. Okay, so this statement here is equivalent to saying now that as z approaches 3a plus b, f of z approaches plus minus infinity. Agree? So now what can we say about 3a plus b? 3a plus b is equals to now you bring back the thing above the line. So 3a plus b equals to 2. Okay, what just happened? What just happened seems a very common question thing. Okay. How many places is fx going towards plus minus infinity? Just look at the graph on the left. How many, okay, for how many values of x? That's what I mean by how many places. For how many values of x is my fx going towards plus minus infinity? One position, okay. So now I have two things here. Number one, fx is going towards plus minus infinity as x goes towards 2. Number two, whether I say z or x here doesn't matter, right? It's just a placeholder. So as f of x approaches whether f of x approaches plus minus infinity as x approaches 3a plus b. But just now we already saw that there's only one value of x for which fx will approach plus minus infinity, and that is 2. So conclusion is that 3a plus b has to be 2. You couldn't have said this if my diagram had more than one vertical circle. But because there is only one, so I can safely say this. Okay, if you find it hard to understand, you go by the transformations approach law. That means to say, right? That means to say, okay, maybe I should have done that with you now. You do your translation, you do your scaling, okay, then you do your translation again. You ask yourself, this fella end up where? Right, so after the translation, x will be x equals 2 minus b. Because you do translation first, right? You will do translation in the negative x direction by b units. Then what do? You do scaling parallel to x-axis by a factor of 1 over a. Then after that, you translate everything upwards by c units. but the vertical asymptote will go upwards. It's still there lah. So answer 2 minus b over a equals 3. Or we ever work out what is b. Okay, and you will get the same thing, lor. You will get the same thing. Eh? The other way around. 3a plus. What's going on? Yeah, so if you don't understand what I was trying to say, then you just use the transformations idea. Okay, then the last one. This one. All you need to do is you sub into the equation. Okay, so 7 equals to f of C is the y, right? X is the 7. So f of 7a plus b is c. Sorry, f of 7a plus b plus c is c. So c will cancel. Okay. Now, if f of x is 0, what is x? Look at the graph, the original graph. There's only one place, right? When x equals 0. So from here, 7a plus b must be 0. So you solve these two things simultaneously. Okay, the reason I can say 7a plus b is 0 is because I will get this step. And the only value of x for which f of x is 0 is when x is 0. 7a plus b came from where? 7a plus b came from substituting 7c into the equation of the second graph. Okay? Yeah. Okay, so let's call this equation 2, call this equation 3. You take 3 minus 2, you get 4a equals to -2. A is negative half. Okay, then you sub back into either one. C is b is 7/2. Okay, then we have come to the end of this lesson. Okay, so on Friday we'll continue with 6, 7, 8. Would you like to take back home a challenging parametric equations question to try? That's the 8 marks. I'll give you lah, huh? Because I'm sure there are a few of you who like silently, actually I want, but I don't dare to say because my classmates all say no. Okay, so I will help these people. You have to review yourselves, okay? This was the one of the 2021 promo questions. Please tell your friends, please. Okay, and I will how to measure the output. Okay, those who came in later, can I have your assignment, please?